what answer did we come up with on this? 4. Okay, that's good. So you had to use the caret button, or you might have a y to the x button, or some of them it's actually x to the y. I've seen both. Okay. Y to the x, that raises to a power. Okay. And what about, let's see here. Oh, some of them you might have to use parentheses. Some of the more basic scientific calculators, you had to use parentheses, so you might have had to put in 8 to the 2 divided by 3 power, close parentheses, then hit enter. Okay, make sure you do that. Let's see here. What about the third root of negative 27? Do you have that button that looks like this, has like an X with a square root sign, so you can find the nth root of any number? Okay. Okay, go ahead and try that, see if you can calculate that on your calculator. And let's take a few minutes to make sure everybody knows how to use your calculator to get these two answers. What does this answer come out to? Anybody have it yet? Negative 3. Yeah. So you should have 8 to the 2/3 equal 4, and the third root of negative 27 should come out to negative 3. So let's make sure you know how to do that on your calculator. Okay, so back up here. Now that we got everybody to have use our buttons correctly, we're going to look at fractional exponents for the next few lessons. Okay. So the question is now, well, why is 8 to the 2/3 equal to 4? Why is the third root of negative 27 equal to negative 3? We might understand this one a little bit better already. That's because, well, negative 3 times itself 3 times equals negative 27. So that's why the third root of negative 27 is negative 3. But what about this fraction stuff? Okay. So here's a truth that you might have seen before, and that is that the square root of x equals x to the 1/2 power. So a long time ago, you probably don't remember this, but when you first started doing order of operations, right, PEMDAS, and that if there were any radicals in that PEMDAS order of operation problem, your teacher told you to do them with the exponents. Okay? Why did they tell you to do that? It's because radicals and square roots are exponents, and they're just fractional exponents. So all the rules you know with square roots, can all be converted or transcribed to fractional exponents. We can rewrite any radical question with only exponents if we wanted to, and that's what we're going to be working on. The nice thing is that all the rules are the same as if they're whole numbers, like regular x to the 4th or x to the negative 5. It's all the same rules. So sometimes we're going to add exponents, sometimes we'll multiply exponents. And it's going to be all the same rules, just with fractions. So, but what about this, to the 2/3? Okay. So here's how I can rewrite 8 to the 2/3 using a radical notation. What it means is that it's going to be 8 squared and then take the third root. So you can see the 2 on the top comes from the inside of the radical, and 3 on the bottom comes from the outside of the radical. So we can convert from fractional exponents to radical notation back and forth as we need to. Okay. One way to remember this is that it's inside, outside, upside, down. We need to make sure we actually put all the numbers in the correct place. We can't accidentally make this 8 to the 3/2. That's a completely different question. So we got to remember, inside goes to the upside. Outside goes to the downside. So inside, outside of the radical, upside, downside, of the fraction. Okay. So very important to not accidentally switch those, because if you switch it on everything, everything turns into a big mess. And then, of course, we can simplify this. What is 8 squared? 64. And what times itself 3 times is 64? 4. And that's how we got 8 to the 2/3 power equals 4. You square 8 and take the third root. Square 8, square the top number by the top number. There that is. And then you take the root of the bottom number. Alright. So we'll be doing a lot of just calculations with numbers where you have to put in your calculator. Sometimes they come out the whole number, sometimes decimals, and it'll tell you to round to this place. Okay. That's actually the second part of your homework, is just really plugging in your calculator and making sure you can use it. And then we'll get into the advanced stuff when we get back from break. Okay. Now, it's one thing to do all numbers. It's another thing when we start incorporating variables. So we start doing the x to the 5/7 power, and what does that mean? Okay. It's basically the same thing as what we already know, with one little caveat. Okay. So take a look at this. Here's a question that's going to be like on your homework, a typical question. Now, what do you notice about the answer? What's new about it? Absolute value. Now, why? Okay. Why do we have absolute value? So let me walk you through it. Yeah, why? Yeah, exactly. That's the first question, is why is there absolute value? Second question is, why is it only on the variable y and not on the x? Okay. So think about, what is the function of absolute value? What does absolute value do to any number or variable? What does it guarantee the answer to be? Well, actually, only positive. Right? Absolute value makes anything positive, right? Now, why would we want to make sure our answer is only positive in a square root question? Yeah, exactly. So we're going to do everything only in the reals, no imaginaries. So we want to make sure that this answer stays all positive. But if I have a y to the third and maybe y equals -2, well, -2 times -2 times -2 would be -8, which would cause me to have a radical, negative inside the radical, which would mess up the whole thing. So we want absolute value here to avoid having any issues of having negatives inside the square root. So think of absolute value is linked to positive. Positive is linked to square roots. And I need to have positive and square roots, therefore I need to make sure I only have positive answers. How can I make sure I only have positive answers? Take the absolute value, and then I have guaranteed always positive answers. Now the second question, how come it's not on the x squared? Yeah. Right, so if x equals -2, well, -2 times -2 is +4. If x is anything negative, it's going to be squared, and it's going to be positive. So I don't need to put absolute value, because it's an even exponent, I already know it's going to be positive. So for the same reason, I'm just trying to ensure that we have a positive, right? Here, an even exponent, it's going to be positive. Here, odd exponent, not for sure. So that's why we put it only on the odd exponents. So as you finish all these problems, you're going to need to make sure on all the odd, only the odds, you put absolute value. So that's a very good open-ended question for your test that's going to be much later, but not too much later. It'll be here before you know it, is how come we use absolute value? Well, when do you use absolute value in the answer, and why do you only use it at that particular time? Okay. That little summary right there. Okay. So let's just do a little practice. You can equate this whole, like, well, when do you put absolute value? It's kind of like maybe, when do you flip the sign of an inequality problem? When do you flip the sign? So if you have like this old-fashioned inequality sign, how do you know when you're supposed to flip that sign? Yeah, if you had to divide by a negative, that's when you had to flip it, right? It's kind of like that. It's a little rule that you have to do sometimes. So you're not going to see it on every single answer, just like on every single problem. You don't flip the negative, but when you happen to divide by a negative, then you flip the sign. When you happen to have an odd exponent answer, you have to put absolute value. So it's one of those little things that's kind of easy to forget, so hopefully with enough practice we'll get good at it. Alright, so we want to simplify some radicals. Here we go. Nice thing is we just get to do the same thing we always did with numbers. Those don't change. So for instance, square root of 12v to the fourth. So let's break it up into smaller pieces. What's the square root of 12? You should get what? Root 4 and root 3, which equals 2 root 3. So I can just do all the numbers just as one little problem, go all the way through, and then do each variable one by one. Alright. Square root of v to the fourth is, same as 2 in front. So we have v to the 4 over 2, which equals v to the second. And that's it. Absolute value here? No? Why not? Yeah. We have one exponent, it's even, that's always going to be positive. No problem. What about something like 2? Okay. What's root 24? What goes into 24? Okay. Root 4, root 6, which is 2 root 6. Oops. Not root 2, but 2 root 6. And then what about the b to the third? Square root of b to the third. Okay, so can we take the square root of b to the third? Does that work? Yeah, if we off to the side here, look at it. If we continued just with b to the third, we'd have b to the 3 over 2. And it doesn't really simplify, right? So, what do we do when it didn't simplify with the 24? Broken into two pieces, one that did simplify, one that didn't. So how can we break up b to the third into two pieces so that one simplifies and one doesn't? B squared and b. Yeah, that makes 3 altogether, right? So this is b squared, b to the 1, altogether there's 3. So see how it's the same steps as I did on root 24. Broke it up into a part I can take the square root of. I can take the square root of b to the second, which is, by the way, b, absolute value, right? And then the second part, like root 6, I can't take the square root of 6, so I just bring it down, it's root 6. I can't take the square root of b, so I just bring it down, it's root b. And there you go. A little side note on notation, remember you can do absolute value this way, so it's kind of like taller, it goes above and below. Or you can do absolute value where you just make it dark and it's the same height. Just make sure you note your absolute values correctly so they don't look like ones. Either make them dark or make them taller and lower than the variable. Okay, good. So I hope you see this as, well, it's really just doing the same thing we've always done with numbers. This whole part right here, breaking up, that's the same thing we always did with numbers anyway. Now we're doing it with variables also.
Why can't you put 6, why can't you put the b only with the 6 and then absolute values with b?
Could do that. If you want to go a little bit further, we could say square root of, 2, absolute value of b, and then the 2 square roots here could be square root of 6b. Yep, that would be okay. And that's good to know because maybe the way you would write your answer in the order and whatnot, you check the back of the book, it might look a little different, but if they're equivalent, like these two, don't say, well, mine's wrong and theirs is right. Maybe you want to know how to write it their way because that's how, all the answers in the back of the book will look like, but good. So very good, good, good. All right, let's try another one with some more numbers in it. Let's say 8. Okay. So square root of 48 is? Okay, figure it out. What is it? Okay. How about square root of m to the 4th? Square root of p to the 4th. Square root of p to the 2nd. So here is what? Anything yet? What's the biggest square root that goes into 48? 16. So what does it reduce to? 4 root 3. Good. Guys, quite today. What about the square root of m to the 4th? M squared. So it's like doing 4 divided by 2 is 2. Same thing here. P divided by 4 divided by 2 is p to the 2nd. And then here, 2 divided by 2 is q to the 1. And is that your answer? Yeah, odd exponent. Remember, a variable by itself is to the 1 power. So yeah, we need absolute value there. Need absolute value. Okay. Let's just do one more because this has some even and odd exponents. These are all odd. All even, so it's nice because they all divided by 2 evenly. So let's kind of combine everything together. One way of looking at this is, okay, first figure out the number. What is that? What does that reduce to? What's the biggest square root that goes into 150? 25 and 6. So this is 5 root 6. And then make up 2 square roots. Just like here I've made up a square root of a perfect square and a square root of a non-perfect square. The equivalent for variables is break it up into even exponents. So like m to the 3, that's going to be m squared and m. So 1, 2, 3. So the first one will have only even exponents. The second one won't have even exponents at all. So p to the 2nd and q to the 2nd. And I need one more q over here to make it to the 3rd. So the first one, I can take the square root of all of these. The second one is the one that drops down. This is like the root 6. I can't take the square root of root 6, I just drop it down. I can't take the square root of m and q, so that just drops down. But here, yeah, I can take the square root of all those, let's divide each of those by 2, and you get m, p, and q. All absolute value. Okay. So we have quite an answer. You can see we have some different components of many of these answers. There's usually like a number portion. There's usually a leftover portion where we couldn't take the square root of it. And there may or may not be an absolute value part of your answer. It just depends on what kind of answer you have. But if you work at trying to set up the variables in the same way you set up the numbers, root 150 is root 25, root 6, the part you can take the square root of, then the part you can't, it'll make a lot more sense. It'll be like, okay, I'm doing the same thing I already know how to do, just with variables. So let's practice a few. Oh my God. 1b, this is a good one. So how would you simplify this? What does this mean? Root, 6th root of 729. What does that equal? Put that in your calculator and see what you get. Of course, if you couldn't maybe figure out your square root, nth square root button, you could always convert this to a fraction. So this is the same as 729 to the 1/6 power. Okay. What answer do you get? It's 3. Yeah. That means 3 times 3 times 3, 6 times is 729. Good. And then do same thing, 6 power of x to the 30. That's the same as x to the 30 over 6, which equals x to the 5th. Okay. How about the 6th root of y to the 18th, which is y to the 18 over 6, which is y to the 3rd. And then absolute value. Both of these are odd, right? Absolute value around all of them. You could do it individual, but it's easier. Looks a little bit nicer. Just all the odd variables we have absolute value. And for now, for time being, I know you guys know that this equals 5i, but for now we're just going to say not real. Alright, anything else looking at you weird that you need to know how to do? Square root of 64 is 8. Square root of y plus 1 to the 14th is square root, right? So that's like y plus 1 to the 14 over 2, which equals y plus 1 to the 7th. Okay, is that correct? Absolute value. Now you're correct. Notice how I didn't make up any new rules like, well, maybe I should just do y to the 14th plus 1 to the 14th and start doing all this fancy stuff. Okay, the y to the first, the part inside the parentheses, just stayed intact the whole problem. We're not asking you to expand anything or do anything. Just know how to work with the exponents on the outside. Even if this was like y to the 3rd plus 1 to the 14th power, this would just be y to the 3rd plus 1 all the way. I'm not going to do 7 times 3 or anything fancy. Just keep it simple. So let's let you guys get going. There you go. Okay. So the first part is kind of what we've been practicing. Up to 22, it's just numbers. Then we add in the variables, so you have to think about absolute value. And then the last part is calculator work. Just make sure you know how to use your calculator. It says round to 3 decimal places, so make sure you do that. And the last 3 are just some review with imaginaries. Okay, so you got the rest of the period to work. Use your time wisely. Ask questions. Do the problems you might struggle with by yourself now. Do the easier ones later.